everyone. My name is Rebecca Bickham, editor of AMP's Materials Performance Magazine. Joining me on today's podcast are Crystal Morrison and John Watkins, who both work for LumaShield Technologies Incorporated. Crystal leads business development, and John is a senior scientist. They recently contributed an article to MP titled Enabling Manufacturing and Fuel Efficiencies with Novel Pretreatment, and I asked them to join me today to discuss this in further detail. Hi, Crystal and John. First of all, thank you for joining me, and how are y'all doing today?
Great.
Yeah,
Thanks
great.
for having
Thanks for having us.
Absolutely. I'm so glad you're here. So the first question I would like to ask you is if you could each briefly introduce yourself to our audience and then tell us a bit about your background. Crystal, I'll start with you.
Yeah, thanks, Rebecca. So my name is Crystal Morrison, and as Rebecca said, I lead business development at LumaShield. My educational background is in polymer chemistry. And after I did my PhD, I worked at Los Alamos National Lab for a number of years, relocated to Pittsburgh and led industrial coatings research at PPG, and now I'm working with LumaShield.
Wonderful. And you, John, same question.
Yeah, so I'm John Watkins. I'm currently the senior scientist with LumaShield Technologies. I'm also one of the original co-founders. So as you can tell, I'm not from Pittsburgh originally. I'm from England. So I started off with my PhD at the University of Bath, and then I moved for a postdoc to Princeton first, and then I ended up in Pittsburgh as well. I got recruited to the U.S. Department of Energy lab here by two of the other co-founders, Dave Lubke and Junaid Nalwala. And that's when I got into corrosion and coatings, and then left to be the senior scientist.
Perfect. Thank you both for sharing that. So why are next generation pretreatment technologies an important tool in improving manufacturing and fuel efficiencies in the transportation industry? Crystal, did you want to take this one?
Yeah, absolutely. So this is a great question, and we are all doing what we can to improve manufacturing, make things more efficient, and also, of course, save on our fuel use. When you think about manufacturing and painting equipment, surface preparation and paint shop operations account for a huge portion of energy and emissions and hazardous waste generation in a manufacturing facility, automotive in particular, but it also applies across all large manufacturing facilities. In fact, in automotive, I think that over 70% of the energy used in an automotive plant actually is associated with paint shop operations. So it's significant amount of energy use, emission, and waste. And so why do we need next-gen pretreatments? Well, conventional pretreatments like iron, zinc phosphates, zirconium-based phosphates, those often require heated baths. They're often limited only to certain metal substrates. There's often a good amount of water that's used, hazardous waste generation, just the solution, as well as sludge formation. And sometimes these baths are pretty difficult to control. And even after you pre-treat the substrate, there's challenges with flash rusting and being able to handle those parts prior to painting. So we definitely need new pre-treatments that are applicable to a variety of substrates, especially substrates that are becoming so important to lightweighting, like high-strength steel and different aluminum alloys. We need pretreatments that work for all of those, and we need pretreatments that produce really minimal waste with no hazard air pollutants, no VOCs, and yet provide superior adhesion and corrosion performance for these parts. So we really need to rethink how we're doing pretreatment. And that's really why we've spent so much time at LumaShield thinking differently about how pretreatment is done, and that's where the technology comes from. So again, it's not just about the pretreatment, it's really looking at improving manufacturing and fuel efficiency, not only in automotive, but in manufacturing as a whole, and looking at not only paint, but how we're pre-treating and preparing the substrates to start with. So I'll pause there, and Rebecca, turn it back over to you.
Okay, thank you. That was a great explanation. My next question is, what can you tell us about material lightweighting and how does it improve vehicle fuel economy? John, I'm going to have you take this one, and Crystal, if you'd like to weigh in as well, please feel free.
Thanks, Rebecca. So the lightweighting aspect is quite interesting from a pre-treatment point of view. I think it's not necessarily obvious how such a small layer like a pre-treatment can actually help overall with lightweighting. So there's like the surface layer is something like our coating is very thin, it's aluminum oxide, it's very light itself, certainly lighter than phosphates. So just by applying that, you're going to gain some weight. And every kilo you can gain in vehicles, that's huge for the industry. So that's the surface level. But then this is where we sort of wrote this article. We're trying to dig deeper into what can we enable with this technology as well. And we break it into a couple of different places. So we know there's a lot of organic coatings that go into a coating system, many layers of paint that go on top. So what we're looking into for our product, for aluminum oxide, is can we reduce the number of paint layers that have to go on top of that pre-treatment, but still either retain or improve the corrosion resistance? So then you're also taking away the weight of additional paint layers. So that's another aspect. But I think probably the biggest thing that we're really looking at is a multi-material approach. So what this means is vehicle lightweighting is looking a lot into, can we replace steels with aluminum alloys, or even in some cases magnesium alloys? So can we come up with a way to sort of replace those things? And one of the barriers that's standing in the way of replacing steels with lightweight materials is in the surface finishing, in the pre-treatments in paints. Can we apply those same coatings to multi-material components? And because that's actually quite difficult with the existing technology, we're kind of limited how much aluminum alloy we can incorporate into a vehicle structure. So what we're really looking at here is, can we use our coating as a multi-material pre-treatment? And we can. So we can put this down onto aluminum, steels, stainless steels, nickel, zinc. We haven't tried magnesium yet. I actually just listened to the one of the recent podcasts talking about magnesium materials, and actually they were saying the same thing. This is one of the barriers to incorporation of magnesium in vehicle structures. And then, of course, we talk about automotive in this article quite a lot, but all the same stuff applies to aerospace as well. Aerospace definitely want to get lighter weight as well, for obvious reasons, for fuel efficiency. Every kilo you can cut off all these structures is going to lead to more efficiency, and then you have all the impacts of less fossil fuel use. Everything is more environmental, and that's sort of the direction we want to go. But it just applies to all of these aspects where you want to get lighter weight. So there's just several pieces to this that we think we can address.
Does that help? Yes, thank you. That's really interesting, John. So we're going to change course here for just a moment. I have a short series of questions I'd like you both to answer, and they're designed to help the listeners get to know you both a bit better. So my first question is, what's your favorite TV show, movie, podcast, book, or sport that you're consuming right now? Crystal?
Oh, I'd have to say that my favorite podcast is Crime Junkies. I'm a true crime fan and a big fan of that podcast.
That's great. Anyone in particular?
Oh, they have many seasons of Crime Junkies, and it continues to be a great show.
Okay, interesting. I'll have to check that out. What about you, John?
Yeah, so actually, it's interesting. You actually left out my favorite medium, which is video games.
Oh, I'm sorry. I'll have to include that from now on.
My favorite medium is definitely video games. Right now, I'm playing a lot of Assassin's Creed Valhalla. That's my current game that I'm playing. But if I have to stick to the exact parameters, I listen to a ton of podcasts as well. So I listen. Right now, it's NFL off-season. I'm a big football fan. And my team is the New York Giants. So I'm listening to a lot of NFL podcasts. I listen to the NFL fantasy podcast as well. Anything like that.
Great, thank you. How did you both get into corrosion research, Crystal?
So actually, even though my background is very much polymers and plastics, when I worked at Los Alamos National Lab, I worked on a lot of military and defense related projects. And, corrosion was always something that we were studying as part of the overall system of components that we were looking at. So actually it started back at Los Alamos, and when I moved to Pittsburgh, worked with RJ Lee Group. We did a lot of forensic evaluations related to corrosion. And then, of course, when I led industrial coatings research at PPG, in industrial coatings, that's one of the top things you're trying to prevent is corrosion from happening. So even though I'm a polymer and plastics person, corrosion has been part of the work I've been engaged in, all the way back to my postdoc.
Understood. And you, John?
Yeah, so that's an interesting question. I'm an electrochemist, so corrosion is right next to what I have always been doing. So the better question is, how did I not get into corrosion earlier, really? So I was at the University of Bath. I did my PhD in organic electrochemistry. I've worked with ionic liquids. And then quite by accident, we invented a process that we just thought, this can deposit aluminum oxide, something like that, onto steels. And hey, what's the applications for that? Well, corrosion seems to be a big one. So I got into corrosion directly, quite accidentally, but I've always been a big fan of electrochemistry.
Okay, great. Last question in this series. Professionally speaking, what's your biggest pet peeve, Crystal?
So my biggest pet peeve is hearing the statement, we've always done it this way. And, that's a statement that you hear a lot of times. It's a statement that people hide behind when they're afraid of change, or they're afraid of really innovating and getting new products and technologies on the market. Is we've always done it this way. And so that, for me personally, is one of my pet peeves.
Yes, that's one we hear all too often. I agree. What about you, John?
Yeah, I really love Crystal's answer, actually. So I think my I was thinking about this a little bit. I think my biggest pet peeve is probably, I see a lot of really great science out there. I see a lot of people developing really good technology, and I think scientists don't put enough emphasis on communication. So I think it's scientists who are fantastic scientists, but bad communicators, be it in written form or presenting or something like that. So there's so much technology out there that feels like it's not getting enough press because of the poor communication. So I really try to get around that, and this is why we're doing something like this podcast right now.
That makes sense. That's something we can all improve on. Okay, well, thank you so much for answering those questions. We'll switch gears again and continue on with our discussion about the novel pretreatment. So can you explain the findings of your research of the aluminum oxide-based pretreatment, and what are the benefits? Do you want to take this one, John?
Yeah, so the research was quite interesting. We started off in a place, I said my background's in ionic liquids, so we started off with the premise of, can we put pure aluminum onto steel out of an ionic liquid, and can that give us corrosion resistance? And I think it can. There's processes that do this, and we wanted to be water insensitive, but we very quickly realized that that's not going to be cost effective, essentially. So we then realized we could still do that same process, but now what we're growing is aluminum oxide. Because we're in water, we're going to essentially grow aluminum oxide. But unlike some processes where you try to grow aluminum oxide, we don't use binders, things like that. We're not sintering this onto the surface. This is electrodeposited directly onto the surface. So what that means is that there's a lot of benefits around using just generally electrochemistry over, say, a more traditional immersion, like a phosphate process. So the big benefit to me is in process control, and that's something I think people don't really think about a lot for their immersion. So when you do an immersion technology with phosphate, you can control a lot of different bits and pieces. You can control temperature, you can control pHs, compositions, additives, concentration of materials. But there's a lot more you can control if you add electrochemistry. I can still control all of that stuff in our aluminum oxide bath, but I can also control things like timings. I can control current. I can control spacings of electrodes and geometry. So we have a lot more knobs that we can turn without having to chemically alter the bath. Now that sounds like, well, great, I can do all this stuff chemically, so why do I need to add all the complexity? Well, that complexity adds into what I was talking about earlier about multi-materials. So we can take the same chemical solution and we can apply it to all these different materials because we can control all of those things separately. So say aluminum, this aluminum alloy requires a little bit of a different current or timing than this one. Well, I can adjust that. And what's also really cool about having something like that ability is that the reactive part of our solution is the electrons you're generating at the surface. So I don't have anything reactive in our solution. I mean, our CEO has joked that you can actually, if you were to neutralize our solution, you could drink it because there's nothing toxic about it. It's aluminum in solution, essentially. Now, what's great about that is that the reactive parts of these other solutions, that's what tends to be the thing that's also toxic. So because we have none of that in the solution, we're very environmentally benign in terms of waste disposal. But I can generate reactive species at the surface, and then they're consumed. And I do that by reduction, by electrochemistry, not by additive. So it just gives us a lot more control over the process in general, while also making it environmentally benign. So I think that answers that, I think.
Yes, that's great information. Thank you so much for that. And also, John, I know our listeners will be interested in this final question. How does aluminum oxide perform as far as corrosion resistance goes?
Yes. So this is something we've had some pushback on before because a lot of what people like to use is something sacrificial, especially when you're talking about aluminum, especially. I've heard this, where you don't have anything sacrificial in the pretreatment. So the performance comes from the adhesion of the paint to the surface. So we are able to metal bond our aluminum oxide directly to the steel in a very, very strong bond. It's a very coherent surface. And then we can use that aluminum oxide surface to chemically bond, again, the paint to that. So we it's like a glue that goes between the paint and the metal surface. And it creates so much adhesion that even when we damage, like you see a standard scribe corrosion test in salt spray, we can damage down to the steel, and we do see corrosion at the steel sites because you've got exposed steel. But what doesn't happen, you don't get corrosion that's able to eat underneath the paint and start to delaminate that paint away from the surface, away from the damaged site. So you're actually stopping the damage just purely by adhesion. Now that's something that we've been working on, is this pure adhesion model. Now that works on all these different alloys I've talked about, but we can also bond a lot of different paints to our surface. Now I alluded earlier to the reduction of different sort of paint layers that go to the surface. Well, usually you're using a phosphate, a primer, maybe multiple primers, and eventually you get to a top coat like a polyurethane, and you're doing that for appearance or for UV resistance. But generally you can't go directly polyurethane onto a metal surface. Well, with our coating, we've been doing a lot of testing where you can do that with the direct-to-metal approach, where we can put our coating down onto the steel, go directly to polyurethane, and we still get all those benefits of corrosion resistance just through adhesion, and we get no delamination of the paint. So I think that's really what that is.
Okay, thank you. That's really valuable information for our audience. At this point, Crystal, I'd like to give you the opportunity. I know you wanted to make some final comments and kind of wrap up our interview, so I will pass it over to you.
Yeah, thank you. So again, we really appreciate being able to talk to you today. One of the things that John and I wanted to share is that we're always looking for collaborators and partnerships at LumaShield. So if you're out there and you're listening and you're really struggling with your current pretreatment, whether it be spending an extraordinary amount of money on waste disposal or facing really regulatory pressure to consider something different, if you want better performance out of your current pretreatment and coating system, if you're looking to enhance your paint shop operations, I really encourage you to reach out to us. We'd love to talk to you about your operations and how to do that. So you're welcome to go to our website at lumashieldtech.com. You can submit an inquiry through our website, Or you're also welcome to email me directly. And my email address is cmorrison@lumashieldtech.com. I'd be more than happy to talk to you about your operations, understand more about the problems you're facing, and how this technology could address those problems and even dramatically improve performance as well as cost savings to you and your customers. So please reach out to us if you have ideas, if you want to talk further and learn more. We'd love to hear from you.
Great. Thank you, Crystal. This is where we'll end our interview today. I'd like to thank both Crystal Morrison and John Watkins for taking the time to join us today. And if you'd like further information on the subject, check out their article, Enabling Manufacturing and Fuel Efficiencies with Novel Pretreatment, which was published in the January 2021 issue of MP. Again, my name is Rebecca Bickham, editor of Materials Performance. Thank you so much for listening.